So hello dear students, in this session I wish to discuss with you various inventory control systems. In the last session about inventory management, we discussed on the basics of inventory control, and a basic economic order quantity model for managing your inventory lot size or the volume. Now we can discuss on various reorder system, or when to order your when to give the next order for replenishing your inventory. So there are very basic systems. It starts with a 2-bin system. Then you can have maximum minimum system. You can have fixed period system and fixed ordering system, that is Q system and P system. And you also can have a just-in-time system, that is JIT. It's a part of lean manufacturing system for a better efficient inventory control. So coming to the 2-bin system, it's very simple. Like you are having 2 bins or baskets. Say for example, you'll be having sufficient stock in the bin. Say both the bins will be full at the first time. Uh, you will be consuming that particular resource from each bin, from a single bin, and once that one bin is completely empty, you will go for the next order. So that is the concept of 2-bin system. So you are consuming you are having 2 different bins. You are storing same product in the same item in the 2 bins. Say for example, if you are running a workshop where a particular type of nut and bolt is required each and every time, it require in a bulk quantity. You are taking that for a bulk purchase, and you are storing that product in 2 different bins. And once your one complete bin is empty, you will be going for the reorder. So if you are having a lead time or not, you can consume from the second bin. So that will always ensure no understocking happens. Means the second bin will be serving as a safety stock. A part of the second bin will be serving as a safety stock with to avoid any understocking. So that is the best way to explain the 2-bin system. You can see over here you are having 2 bins, 1 and 2. Inventory is being utilized from 1 bin, and soon after your first bin is empty, you will be going for the replenishment order or reorder with the supplier, so that the supplier can order it in a proper time, and you will maintain a proper inventory in your organization. Next one is a maximum minimum system, where again instead of 2 bin you are having only 1 bin. In that particular bin you will be having 2 lines. One is your maximum line and the second one is your minimum line. Once you are having your items or products in the maximum line, you can start utilizing your product, and that will be consumed, and that minimum line will be reached. So when you reach the minimum line, you will be ordering your next order. You will be ordering with your, or you will be placing your next order. So here the next order will be the quantity of that next order will be only to reach the maximum level. Selective, you are simply drawing 2 lines representing maximum and minimum amount, and you can't order more than your maximum line. That is a major thing, and it's a very simple approach. It can be good or a bad thing, because maybe if you need to face a much lead time, and your whatever holding thing after your minimum level, if that won't suffice your requirement, then it can go for say understocking. The next one is what we already discussed in our EOQ model, that is your Q system, that is fixed size ordering system. So you'll be having a safety stock and economic lot size. So as discussed earlier in the previous session, you will be having your economic load size for reordering, and you will be defining a reorder point based on the lead time. So once your usage line or usage reached your reorder quantity, then you will put your next order, replenishment order, and it will take a lead time to reach your particular product to reach your warehouse. So that time your quantity economic or earlier quantity being utilized, and then once it is replenished, your stock is back in the maximum. And you can always maintain a safety stock you to foresee uh, any surge in demand or any say what unforeseen situations like this. So this is a Q system. Now coming to the P system, here it is a fixed period ordering system. You, instead of a reorder point quantity, you will be ordering based on the time. So once you are fixing an ordering cycle or an ordering time, and once you reach that particular ordering time, you will definitely put the other order. Like say you are putting orders say in once in 2 months, say based on how much you won't be considering how much quantity is being consumed. Once you are passing 2 months, you will put the next order, and after 2 months again the next order, like that. So that is being shown as a graphical representation. That is fixed period. So fixed period, and earlier it was fixed size. You can see the difference in the graph. Now the last one is the just in time inventory management system. It is like your material arrives just in time when it is needed. So once you are getting an order, only you are purchasing or delivering a material on site, and that always try to minimize your inventory management cost or inventory carrying cost. Toyota is a major example for implementation of JIT, and JIT is actually a part of lean manufacturing system where you are definitely trying to avoid waste. Because waste is a major cost that is being faced by all production industry. So keep an idea about just-in-time inventory management system. Now we can just go for how we can do a selective inventory control, because you will be having a wide variety of items required in a production plant, and which items you need to always have a better control. So that is selective control strategies. There are some 6 to 7 control strategies, and we will be discussing the major 6 things here. First one, or the major one that is being utilized in industries, are your ABC analysis. So in all types of these control strategies, you will be controlling based on the value, usage, and frequency of consumption. If the value of that item is very low, you don't need to have a much control. You can go for say 2 bin system or maximum minimum system. No need to go for a fixed ordering, fixed period, or fixed quantity, or just in time ordering. You can go for some very limited control is required. But if the quantity or if your value is very high, suppose a product is or a component is costing you lakhs, or say thousands, much thousands, then definitely you need to control the cost or control the its overall cost. So for that, first we can analyze on ABC analysis. ABC analysis is you are classifying the items based on its value, say a value and consumption. So A items where you will be having annual consumption is very highest, and it will cost only say 10 to 20% of your total inventory item. It can be better explained in a graph. Say for A items, you will be having very tight control, and complete and accurate records will be there, frequent review will be there. And for B items, less control will be there, records and regular will be there definitely. And C items, you will be having minimal records and simplest control possible. So A, B, and C in a graph, it will be like this. Based on the value is at the y-axis, and percentage of items is in the x-axis. So you can see that A items will be very low in number, but the cost or the value will be very more. Suppose you are having say you are having an automobile, and comparatively I am taking engine as a whole, transmission, engine, everything as a whole, and your other assembly parts as the secondary things. So you can take that the engine and other transmission assembly will be the A part, that is having much value, and the number will be very less. And when you consider the rivets or your nut and bolt requirement, it will be very high, but the cost is very low. That comes under the C1 category of C. And the intermediate ones will be like, say, other assemblies required or other components, or say your body parts required will be the B thing, where you require a less amount of control. So you can classify your required things or required inventory like ABC, and based on the value or say category A, B or C, you can implement different control strategies to optimize the cost. So the same graph in A, B and C. Another graph say based on your cumulative percentage of cost, it will be like this. Now the next type is HML analysis, where your HML is based on high cost, medium cost and low cost, similar to ABC, a little more similar, little similarity with ABC, but here only you are considering the unit prices. You are not taking the consumption, you are only taking the unit prices. You can classify like high cost, medium cost and low cost. Definitely you need to control your high cost things, and low cost things you can have a very moderate or very lenient control. Now we can go for a VED analysis. VED is actually based on the criticality or impact of that particular component in the production process, that is vital, essential and desirable, VED. So vital is very important because if a particular item is missing, your production time is delayed for a or production cost will improve because of the lead time. That item is called as vital. Then the next one is essential and next one is desirable. So you can see the chart where based on the average working hours, if a particular item, missing item will cause a increase in average working hours, say more than 4 hours, that you can take it as vital. So it's only an example. It is best suited for spare inventory, spares and maintaining the stocking level of spare parts. VED is normally utilized. Next one is SDE. SDE is based on the scarcity of supply. Here you are looking for the supply, or definitely main warehouse people will definitely go for SDE analysis, whether the item is scarce or not. It will also depend on say your lead time, geographical location and how reliable your suppliers are. So the chart will be like this. You will be having scarce item, difficult to obtain item and easy to acquire item. So easy to acquire items require only very less control. Next one is the FMS analysis. FMS analysis is based on the issue or rate of usage of spare parts. It will be based on how frequently the parts are issued and how frequently your items are being utilized. So you can have fast moving, medium moving and slow moving, that is FMS. Fast moving items may require better control. Medium moving will be requiring less control than fast, likewise. So that is based on the time of consumption. Now the last one is SOS analysis, that is not safety or that one. It is actually seasonal, off seasonal, like umbrellas and all. You can find out you are having seasonal or off seasonal systems. That will be limited period. During the season the demand will be very high, and during the off season your demand is very low. So based on that you can buy or stock your inventories. So this particular strategy is definitely for those seasonal type of goods. Based on these discussions, we are completing our inventory management basics. Definitely you need to look on to your textbook for further details and further numericals in inventory control. You can contact any point. Thank you.